Good morning. So far, we have seen about what about an error and the error analysis overall. So today we are going to see about what about the characteristics of transducer. So before going into an study of the characteristics, let us see about what is an transducer. So consider the following setup of a measuring system. So here we will be having about an block which consists of an sensor, signal conditioning unit, and data representation. Okay. So in the physical quantity, we'll be using of an input signal overall. So which will be sensed by the sensor. So we'll be getting of an output to be a directed quantity. So that quantity will be as an non-electrical quantity, which will be given as a non-electrical quantity. So when it is given to a signal conditioning unit, the non-electrical quantity will be converted into electrical quantity. Okay. So finally, the output will be given to an data representation device. Okay. So this will be continuing, or this will be the block of an transducer. So the input quantity, which is to be a non-electrical quantity, which will be converted into an electrical quantity. So when you are saying about a sensor, actually a sensor is a device which is used to detect changes in any physical quantity like temperature, speed, flow, level, and pressure. Okay. So any changes in the input quantity will be detected by a sensor and it reflected as the changes in the output quantity. Okay. So both the input and output quantities of a sensor are physical overheads and that is to be the non-electrical in nature. Okay. So this is about your sensor, and whereas transducer, it is a device which converts one form of energy into another by the principle of transcription. So usually a signal in one form of energy is converted to a signal in another form by a transducer. So from the above example, so what we can say it of Arena, so a transducer is a device that converts a physical quantity into an electrical quantity. So what about sensors and actuators? So from the definition, what you can be able to know, actually both sensors are devices that respond to a physical quantity with a signal, whereas the actuators, the devices that respond to signals with a physical movement, which can be considered as an transducer overall. Okay. So this is about it. So let me consider the block over here. So we'll be using of an microphone, and then we'll be having of an which is amplified through an amplifier, and then finally we'll be having of an loudspeaker. So what is about a microphone? That will be used as a sensor. So suppose if we are giving the communication over it, so just it will sense the signal. So what is the function of microphone? It converts sound wave into electrical signal. It will convert sound wave into electrical signal. That will be doing in the case of an microphone. So it will be fed to an amplifier. So in order to amplify the signal over on it, then finally we'll be processing to an loudspeaker. So whereas the loudspeaker is an actuator over here, whereas the loudspeaker is an actuator. So what does it do? It converts electrical signal into an audio signal. Okay. So actually the both microphone and loudspeaker are to be the transducers over on it. Okay. So the next we have to see about what about the characteristics of transducers? Actually, the performance of the sensor or a transducer and a measurement system which can be analyzed through two different characteristics. One to be the static characteristics, another one to be the dynamic characteristics. So what is static characteristics? It is used to analyze the performance criteria of a measurement system if the quantity being measured is constant or varying by slowly. Okay. That is shown the relationship between the input and output when measured, and it remains constant or varying very slowly. What about the static characteristics are? The static characteristics are to be the accuracy, sensitivity, reproducibility, drift, static error, and the dead zone. Among all the static characteristics, actually the first three characteristics is accuracy, sensitivity, and reproducibility or desirable, and the remaining three characteristics, drift, static error, and dead zone, or to be the undesirable. Okay. In addition to the above characteristics, we'll have the below parameters which also considered to be as an static characteristic. So let me see what are all the things. So we'll have a precision, second one to be the stability, third one to be the resolution, fourth one to be the threshold, fifth one to be the repeatability, sixth one to be the backlash, seventh one to be the hysteresis, eighth one to be the linearity, ninth one to be the range of span, tenth one to be the bias, and the last one to be the tolerance. So these are all about the static characteristics of a transducer. So let me see what about the accuracy. What about accuracy? Accuracy of an instrument is a measure of how close the output reading of the instrument is to be the correct value. Okay. So the point accuracy. So this is the accuracy of the instrument only at one point on its scale. Only at one point on its scale. And the specification of the accuracy does not give any information about the accuracy at other points on the scale or in words. So it will be given only one point at the scale. And also it not give any information about the general accuracy also. That is to be the point accuracy. So when you are saying about an accuracy, it is a measure of how close the output reading of the instrument is to the correct value. So the accuracy can be as a percentage of scale range. At the same time, it can be as a percentage of true value. Okay. So when an instrument has a uniform scale, so its accuracy may be expressed in terms of scale range. Similarly, the accuracy is specified in terms of true value of the quantity being measured. So, for example, we know that this 0.5 percentage, there is with the percentage or minus 5.5 percentage of the true value. So, the accuracy can be percentage of scale range or by means of an true value. The next one to be the precision. So, it is described as the degree of freedom from random. So, if a large number of readings are taken of the same quantity by a high precision instrument, then the spread of reading could be very small. Actually, the precision is often, though incorrectly, confused with accuracy. High precision does not mean anything about measurement accuracy. The high precision instrument may have a low accuracy. Low accuracy measurements from a high precision instrument are normally caused by a bias in the measurement, which is removable by recalibration. So the precision is described as the degree of freedom from random cells. Okay. The next one to be the stability. So what is stability? It is an ability of a measuring system to maintain the same output over periods of time for a constant input. Okay. So it is an ability of a measuring system to maintain the same output over periods of time for a constant input. So zero stability. It defines the ability of an instrument restored to zero reading after the input quantity has been brought to zero, while other conditions remain the same. So that is to be the stability overall. The next one to be the resolution. What is the resolution? Resolution is defined as